So the problem is, as I was mentioning over here, DHCP doesn't keep your session alive. So basically, if you start over here, let's take this example. So I'm walking along with my laptop. I have Skype open. I'm talking to Matt's talking to his mother in South Africa. Walking along, suddenly he leaves the 1.star network and enters the 2.star network. His computer now acquires a new IP address on the 2.star network. But as far as Skype is concerned, it's still sending packets to the 1.star IP address. So all those packets are lost, the session is broken, and Matt's no longer talking to his mother.
That could be like a testing. Not complaining on this.
That's right, that's right. So that's a problem. The problem is that if an IP address changes during a session, all connections are reset. So now again, we start talking about what's the easiest thing to do. So we could go and say, well, clearly what Skype needs to do is they need to rewrite all of their software to possibly handle the fact that IP addresses will change. But not just Skype would have to do that, but every internet server in the world would have to update their software. So that's not an elegant solution. What we want is a very tight, compact solution that can be deployed in a confined way that basically hides the details from anyone who's writing an internet server. Question back to you.
I was just going to comment to say they pretend it's the same IP address.
That's exactly what, yeah. So, and engineering's full of this. Engineering is full of cases where we have a legacy system and we have a new application. We're trying to figure out a way to adapt the problems in the legacy system to the new thing we want to do. What's the question over here?
Why does the IP address number change if you're, say, it's area or it's all over Europe? So we're moving from one access point to another access point. Why would the IP address change? I mean, we can configure all the routers to be.
So okay, it depends on how they've set it up, and I have no idea how they've set it up.
Okay.
So it's possible that the hubs are not acting as routers, that they're all located on like a central Ethernet or something like that. In which case, all the packets are sent to every router, or all the packets are sent to every hub. In which case, there's no routing going on, so the problem that I've described doesn't exist. If that's true, then yeah, you should be able to walk from access point to access point.
Because we can create virtual LANs and put all the
That's
routers on the one LAN. And then
That's true. So my only issue is I'm basically certain that Wi-Fi doesn't do handoffs as it was originally set up, and I don't know how they've set it up in Area. Okay, so in other words, all connections are reset, which means if you're downloading a large file, or receiving a stream, that download is broken. So that's bad. So if you're trying to download some uncertain legal peer-to-peer music or movie to your cell phone, and you walk from domain to domain, and your IP address changes, you're screwed. So you basically lose that download. So in other words, if the world ran on DHCP, what we would demand is that if you're downloading a large file, you have to sit still. Of course, that's not acceptable. So let's find another solution. What we really need, as I alluded to earlier, what we really need are two addresses. fixed and one moving. So it's like I said, it's like my analogy with my parents. I have a fixed address, which everybody sends their mail, and then the fixed address will forward it to my moving address. So let's call these.
What's the dynamic DNS?
Say again?
Dynamic DNS. Get a
Yeah.
host name, when your IP changes, just links it to the new IP.
Yeah, that's right. In fact, I believe there's a way to solve this problem with dynamic DNS too, but
That's just with the host names, not
yeah, just with host names, that's right.
the URLs. Anyway, DNS is application.
That's, yeah, you're right. Okay, so we really need two addresses. We're going to call them the care of address, or COA, which is, this plays the role of the topologically correct address. This is the moving topologically correct address. And this is the current location of your device in the IP world. Or the current routing location. Of the mobile node in IP. And the second thing we're going to have, we're going to call it the home network address. Or HNA. And this is the fixed address.
Every person in the world has a computer.
It's a permanent address from the outside world's perspective. And we keep the HNA so that our IP address doesn't change in the middle of a session, and we keep the COA to ensure that packets actually reach us.
Sir, I have a question.
Yeah.
So, if at home I set up my static IP address that's connected to the router to 130.63.92. Whatever, I can do that, right?
You cannot do that. That's right.
No, I cannot.
You cannot do that.
What's going to stop me when I do that?
Oh, okay, you can do that. It's just that packets will never reach you because your upstream router is not going to forward the packet to you because the 130.blah router, that route is being somewhere else. So you're perfectly free. It's frowned upon, but you're perfectly free to assign yourself any IP address you like, as long as it's unique. If it's not unique, then
Within
that's
the same
absolutely not allowed. Yeah.
Yeah.
But you can assign yourself any IP address you want. It's just that the routing table won't find you. You'll just be an isolated node. Okay. So fine, we have these addresses, but now we need a mechanism to ensure that the whole thing works.